Honors Math 2, Unit 6, final review for the fall final. When I think of Unit 6, I think of the key word is the word similar. If I were thinking of what the main idea was, when I look at Section 2, it has similar polygons. Section 3 was triangles similar. Section 4, similarity in right triangles. And then proportions, dilations. So the key word for this whole unit was the word similar. The word similar meant the same size but a different, the same shape but not necessarily the same size. They were, this key word, proportional. If you don't know what that word proportional means, Section 1 is where we defined it. Section 1 was where we said proportions were where two ratios were set equal to each other. When two ratios are set equal to each other, their cross products were the same. That's kind of when I showed you that picture. Do you remember how to pronounce that word now? Yeah? I saw it the other day and I thought, man, I teach this when I teach cross products. Crossing, in case you forgot that part of that thing. So proportions and similar objects are going to be somewhat the same. What we introduced to you was something called the scale factor. The scale factor represented what was the size comparison from one to the other. And the order mattered. It wasn't the thing you multiplied by, rather it was what's the ratio. And so if they say the left side to the right side, then you have to put the left side first and the right side second. If they say the larger to the smaller, you have to put the larger number first and then the smaller number second. I remember when I graded these tests for you guys, the people who earned half credit were the people who did not put it in the right order. They got like a lot of minus ones. Minus one in Mr. Paramo's class means you made a small mistake. You didn't follow the order. You did something small, not a big mistake, but a small mistake. We talked about how to set things up if you were using the small triangle compared to the big triangle. You have to do like left side over bottom, left side over bottom. It has to match when you set up your proportions. And so the whole chapter was about setting two things equal to each other using similar objects to find missing sides. You could set up proportions. Then we went into 3 postulates and theorems that prove triangles similar to each other. Angle-angle similarity, SAS similarity, SSS similarity. If the sides are proportional, then the two triangles could be similar. If the angles were congruent, 2 pairs of angles congruent is all we needed. So these 3 things, we had to be able to prove one triangle similar to another. We looked for overlapping things. We also could use similar triangles to find the object of very, very tall things that would be almost impossible for us to figure out, just like trying to measure from here up to the top of a palm tree. That would be hard. But with similar triangles, we could just use a shadow, which is easy to measure, and a height, and a shadow and a height at the same time of day. Those are going to be similar triangles by angle-angle. Bless you. So in these, in this chapter, we also learned that an altitude of a right triangle splits this triangle up into 3 similar triangles. Small, medium, large, small, medium, large, small, medium, large. I asked a question on the Chapter 6 test that said, hey, which triangle is similar to which triangle? And the order mattered. If you were going small, medium, large, you would have said ADC would be similar to small, medium, large, CDB. And then small, medium, large, ACB would be the third one it's similar to. And then they would all match. So you could use that to figure out what missing sides were. A lot of times in these kinds of problems, you would do something like a short side and a middle side, 3 over y, and then you'd have to use another equation that has a y involved, 3 over y, because short over middle. And then I'm going to use this other triangle, short over middle. A lot of times you're going to get that the y or the variable is across from itself. And that's okay. Y times y is y squared. 3 times 9 is 27. You sometimes are going to get, most of the time you will get something like this. Solve by square rooting. And so we use similar triangles to solve a variety of different problems. The last 3 examples were in section 5. They use side splitter, corollary to the side splitter, and then the triangle angle bisector theorem. So those are 3 different ways things could be proportional. I just had to make sure you remember that, don't get it confused with the bottom. Since this cuts this side and this side, that's what's proportional, not the XY and the RS. If it deals with the RS, the parallel lines, those ones you're going to have to use small triangle, big triangle to set up your proportions. Lastly, dilations were also part of this chapter because those dilations are similar to each other. They are proportional to each other. If you're dealing with the dilation and you're trying to figure out what the scale factor is, it's always image divided by preimage, after divided by before. Or you can use any corresponding sides for that matter as well. And we talked about how to do it, but the main idea was figuring out scale factor and proportions and to use it to find missing sides. That's pretty much Unit 6. I'm going to stop right there.